So today we're going to be looking at hydrocarbons, okay, namely alkenes, alkynes and alkanes. Okay, so to start off with, we're going to learn how to name these molecules. Okay, so I'm going to write down a list of prefixes that will help us name the first part of the molecule. Okay, so here you can see that I have labelled I've got the prefixes here for the start of the different compounds that we'll be looking at today. Okay, so to start off with, what is a hydrocarbon? Okay, so just look at the word here, hydrocarbon. It's going to have hydrogen and carbon. So there's carbons bonded only to hydrogen. Okay, so let's draw a quick example of a hydrocarbon. We might have, so let's go like this here. Okay, so this example here is called propane. Alright, we'll get to naming that, how to name that in a second. But as you can see here, I have 3 carbons. Okay, 1, 2, 3. And they are all labelled, they are all connected to hydrogen atoms. Okay, so hydrogens and carbon, that is the only bonding that is occurring. Makes it a hydrocarbon. Okay, so there's a few different types of hydrocarbons that you should be familiar with. Okay, and they are alkanes, alkenes, okay, and also alkynes. Right, so these 3 here, they're the 3 main different types of hydrocarbons. Okay, they're kind of the basic molecules that you'll find in organic chemistry. Everything that you name kind of follows a similar principle to naming alkanes. Okay, so it's important to understand this now to kind of build upon that and understand how to name different types of molecules as well. So with this one here, if you look at my example, so grab your colour. Okay, so first step is to count the number of carbons in the carbon chain. Okay, so carbon chain just means these carbons here. So we've got 1, 2, 3 carbons. Okay, and they're all connected in a carbon chain. So we've got 1, 2, 3 carbons. Alright, now what I forgot to put here was beneath is 1 carbon, eth is 2, prop 3, but 4, pent 5, except x6, sept 7, and oct 8. Okay, so, and that represents the number of carbons in the chain. Alright, so this one here, we have 3 carbons in the chain. Okay, so I'm going to look at this, these prefixes here. We go down, we've got 3 carbons in the chain. So the prefix or the start of the word is going to be prop. So this one here, the start is prop. Okay, but we still don't know the suffix or the end part of the word here. So we know it's pro something, and then the second part of the word or the suffix comes from these different types of hydrocarbons here. So depending on whether it's an alkane, alkene or alkyne will determine the suffix. So let's look at the differences between them. So an alkane is only single bonds, okay, which is what we have here. So only single bonds. Okay, only single bonds. Now, if you look at this one here, this is an alkane because we only have single bonds between the different carbon atoms here. Alright. Now, an alkene is when we have at least 1 double bond in the molecule. Okay, so that is So at least one double bond. Okay. Alkyne is at least one triple bond. Okay. Now I'll show you an example of a few of these in a second, but this one here, this is just a alkane. Okay, so the reason for that is because we only have single bonds represented by these straight lines here. So these are the bonds between the carbon atoms. They only have one line between the carbon atoms representing a single bond. Okay, now if we look at all of these different bonds here to hydrogen and carbon, they're all single bonded. Therefore, if we go up here, only single bonds, it is an alkane. Okay, and that's going to help us with the suffix. So the suffix actually comes from the term alkane, and it's the second part here. It's the ane part. So we have prop, we have 3 carbons in the carbon chain, and we know that it only has single bonds, so that leaves the end part of the word, the suffix, to be ane. So this one here, propane. Okay. It's the same with alkenes and alkynes. We'll get into another example soon. But an alkene, instead of writing ane here, say we have double bonds, we would write ene, and the same for alkyne. The suffix would be ine. Okay. So that's an example of a alkane. So this one here, alright, that is a alkane, which is a form of a hydrocarbon. Okay, so all of these here, these are all hydrocarbons. Alright, okay, so now let's look at an example of an alkene. Notice this one looks a little bit different, but it is still a hydrocarbon. Okay, so we still only have carbon and hydrogens in this molecule here. So we have carbon bonding to hydrogen on both sides of this molecule here. The part that's different is the double bond. So we notice in the middle between these 2 carbon atoms, there is 2 lines here which represent a double bond. Okay. Now this part here, the double bond. Okay. This part is what makes it a alkene. Alright. So that's what makes it a alkene. It's the presence of that double bond between the carbons. Okay, so same process. So the first step in naming this molecule here is we're going to, so I'll write a little checklist here. Step 1, find longest carbon chain. Our longest carbon chain. Okay, that's the first step. Alright, so let's look at this molecule here. How many carbons do we have that are connected, that are bonded together? We only have 2 carbons. We have this one and this one here. So, number of carbons in the chain, we have 2. We go across to the prefix here, which is eth. Okay, so we know that the first part of this molecule is going to be eth. Alright, so I'm going to write that down here. Eth, we don't know the suffix just yet. Step 2, determine what hydrocarbon. Okay, so determine what hydrocarbon this actually is. Okay, now we have our hydrocarbons over here, so it could be alkane, alkene, or alkyne. Difference between them is the type of bonding present in the molecule. Double bond here, we know that alkene has at least 1 double bond. Okay, so with a double bond, we know that it's an alkene, and the suffix is going to come from that ene of the alkene. So I'm going to write ethene. Okay, let's write that again. So right there is ethene. Okay. This molecule is ethene. Alright, the eth comes from the number of carbons in the chain, and the ene comes from the type of hydrocarbon that it is. Alright, now let's go through alkynes. Okay, so let's have a look at this molecule here now. It's a little bit different, looks a little bit funky because we have 4 carbons here and we also have the presence of this bond here. Alright, so notice that we have a triple bond here. Okay, so because we have that triple bond, that is going to change the type of hydrocarbon that we're dealing with here. So it's still going to be a hydrocarbon because you only have carbon and hydrogen in the molecule. Okay, and we have to name it using the same rules here. So the same rules for all the different hydrocarbons, and for the other molecules, and then when we are naming molecules in organic chemistry, we use the same kind of steps. Okay, so we're going to find the longest carbon chain here. Longest carbon chain, you can see we have 4 carbons. Alright, carbon 1, 2, 3, 4. Okay, so now we're going to go to the table here. Number of carbons in chain, 1, 2, 3, 4. Okay, go across the prefix. Prefix is bute, so as it start of our molecule. So it's bute something. Okay, now let's look at the end part. Okay, what type of hydrocarbon is it? We have the we have the triple bond here. Triple bond indicating that it is a alkyne. Okay, so the suffix is going to be this "-ine" here. So butene. Alright, that is the name of this molecule here. One more thing that I would like you to notice about this molecule here is we have 4 carbons, okay? And each one of those carbons has 4 bonds attached to it. So if we look at this carbon here, right, we've got 1, 2, 3, 4 bonds associated with that one carbon, okay? And notice that each carbon has 4 bonds. So even this one here, it has 4 bonds, right? We've got triple bond here to this carbon and another bond to this hydrogen. This one here also has 4. 1, 2, 3, 4. Okay, so when we draw these molecules, which will be in another video, when you draw them, you have to make sure that there is the correct number of bonds for each of the carbon atoms. Alright, just a little side note there. Okay, now let's go through some examples. Okay, so let's have a look at this molecule here. We're going to try to name it. Alright, so step number 1, find the longest carbon chain. Longest carbon chain here, we have 1, 2, 3 carbons, right? So go to the table, number of carbons in chain, 3. The prefix is going to be prop. Alright, so the start of the word is prop. Don't know the suffix just yet. Okay, what kind of hydrocarbon is this here? So what bonds are present? You can see that we have a double bond between these 2 carbons here. So we have a double bond. Okay, so we know that's going to be an alkene, right? Because we have a double bond. So the suffix is going to be in this molecule here is prop. So let's look at this example here. Okay, we have another organic molecule. We're going to use the same method here to determine the name. So on this carbon chain, we have 4 carbons in this chain. Alright, and the type of hydrocarbon that it is, we know that it is a alkane because we only have single bonds present in the molecule. Alright, only single bonds here. Nothing fancy going on, so we have a alkane. Alright, so the prefix is going to be bute. Alright, so there's 4 carbons in the chain, and the suffix is going to be "-ane", so we have butane. Okay, that is the name of this molecule here. Now let's say this molecule changed a little bit. Okay, so let's say we took this molecule here and we had a double bond present right here. Okay. Alright, so let's say we have this molecule now. This molecule here is going to be an alkene because we have that double bond. So it's going to be an alkene, but the naming is going to be a little bit more complicated, just a tiny bit. We're going to follow the same rules, but we're going to have to indicate the position of that double bond here. So we have to tell based off the name, what carbon this double bond is on. Alright, so a little bit more complicated, but very similar process, okay? So we're going to start by finding the longest carbon chain again. Okay, so 1, 2, 3, 4. So the prefix is going to be but. Okay, so that's going to be, yeah. Suffix is still going to be ene. Okay, so it's still going to be a variation of butene. Okay, so we still have butene. Where this is a little bit different is we have to say the position of this double bond here. So to do that, I'm going to have to label each one of the carbons here. So I'm going to call this carbon here carbon 1. Okay, carbon 2, carbon 3, alright, and carbon 4. So all I did there is just label each one of those individual carbons, okay, assign them a number. Now, we have to tell what carbon that double bond is on. So, I'm going to count from the right, from number 1 to 4 here. So we're going to go 1, 2, and the carbon before the bond is the carbon that we indicate the bond to be on. So what I mean by that is we would have 2 butene. Alright? Now we wouldn't say 3 butene because we want this number out the front here to be as small as possible. Okay, so we wouldn't go, actually 3 butene would be incorrect anyway because 1, 2, 3 butene would indicate that the double bond is actually between these two carbons, which doesn't make any sense, okay? So we're going to have 1, 2, this carbon here, and the bond after that second carbon is a double bond, okay? That's what we've said with this number out the front here. We've indicated what carbon that double bond is on. Now I want to show you something else here. Let's say we label them the other way around, okay? Now the name doesn't change, okay? Because even if we count the carbons from this direction to that direction, that double bond is still going to be on the second carbon, okay? So for this particular molecule, it doesn't matter which way we look at it, we're still going to have the same name. Alright, 2 butene. Now I'm going to go through one more example. Alright, so we have another molecule here, another organic molecule. This one looks a little bit different, as you can probably tell, because it goes around and kind of goes around the corner here. Okay, now this is just drawn a little bit differently, but we use the exact same rules to name this molecule. Okay, now we are going to have to indicate the position of this double bond. Alright, so we can see that it does have that double bond, therefore it is going to be an alkene. Okay, so I'm just going to circle this, yeah, alright, and indicate that it is an alkene. Okay. Now, let's start by counting how long that carbon chain actually is. Okay, so the carbon chain can go around a corner, let's say that. So we can go 1, 2, 3, and it doesn't stop there, it keeps going down here because this carbon is still attached. So technically I could move this whole section here and put it up here, it would still be the same molecule. Right, I've just drawn it a little bit differently to show you how I can represent it in some different ways sometimes. Right, so we've got 1, 2, 3, 4, 5. Okay, we have 5 carbons in this molecule. So I'm going to go to the table here. Number of carbons in the chain, 1, 2, 3, 4, 5. Okay, the prefix is pent. So I'm going to write pent. Okay, now it does have that double bond, so we know it's an alkene. So the suffix is ene, pentene. Okay, now we have to indicate the position of that double bond. Okay, so one more thing when we indicate the position, we want that number to be as small as possible. Okay, so let's have a look at this molecule now. If we label the carbons this way, right, so we call this carbon 1, carbon 1, carbon 2, 3, 4, and 5. Alright, we could say that the double bond is on carbon 2. Okay, now let's look at it the other way. So we can either say 2-pentene, or let's look at it another way. Let's say we labelled the carbons in the reverse order. Okay, so let's say we make this one here carbon 1, carbon 2, 3, 4, and 5. Okay, so if we look at it that way, then we say the double bond is on carbon 3. 1, 2, 3. Right? 3 and then the double bond. So we could think that it's also 3-pentene. Alright? Now, both of these options indicate the same molecule, but one is more correct than the other. So if you did say 3-pentene in your exam, you would still get marked incorrect, okay? Because that doesn't follow the IUPAC naming conventions. Alright, because we want this number out here to be as small as possible. Alright, so the smaller number out of the two is going to be 2-pentene. Alright, so this one here is actually incorrect because a name exists where this number out here is smaller. So this one here, 2-pentene, that one is the correct one, okay? 2-pentene. So if we label them the other way, okay, so we actually need to go 1, 2, 3, 4, 5. Alright, because then we have 2-pentene instead of 3-pentene, therefore 2-pentene is correct. Alright, that pretty much covers all the naming conventions for hydrocarbons. Alright, once you figure out the naming, it becomes a little bit easier to draw these molecules too. So yeah, that's pretty much it for this video.